Now we're going to look at how to determine the area of a parallelogram. As you already know, a parallelogram is a plane shape which has two pairs of parallel sides. As you can see, two pairs of parallel sides that are opposite to each other. So in a parallelogram, you have two pairs of parallel sides. So I've shown the first pair in black and the other pair in red. So a parallelogram has two pairs of parallel sides. It's a four-sided shape, it's a quadrilateral with two pairs of parallel and opposite sides. The area of a parallelogram is equal to the base of the parallelogram times the perpendicular height. So what I'm going to do is label each side of the parallelogram. Now, for a parallelogram, opposite sides are equal. So if I label this side as having a length of A, this side is also going to have a length of A. If this side has a length of B, this side is also going to have a length of B, because opposite sides of a parallelogram are equal. So if I choose this side as my base, the area of the parallelogram is going to be equal to the base times the perpendicular height. What is the perpendicular height? Well, the perpendicular height is always the height of a line that is drawn perpendicular to the base. So in this case, our base is a horizontal line, so a line perpendicular to the base must be vertical, and that's this line here, and just goes up to the top of the parallelogram. This line is perpendicular and we need this height. Therefore, the area of a parallelogram is going to be equal to the base times the perpendicular height, which is h in this case. So let's consider an example. This is a parallelogram, so opposite sides are parallel and equal in length. Let's say that this side has a length of 10 centimeters and this side has a length of, let's say, 6 centimeters, and the perpendicular height of the parallelogram is unknown. And let's say that the length of, let's call this point A, call this point here point B. Let's say AB has a length of, let's say, 8 centimeters. If you're required to determine the area of this parallelogram, the first thing you need to do is identify the base. In this case, I'm going to choose this side with the length of 10 centimeters as the base. So my base is 10 centimeters. Now all I need to do to determine the area of the triangle is determine the perpendicular height. And that's this height shown here as h. I should call it HP to be honest. But I'll just note down that this height is actually HP, perpendicular height, because the vertical line drawn here up until the top of the parallelogram is perpendicular to the chosen base. How do we determine this height? Well, the height is unknown and you need to determine this height. You need to notice that there's a right angle also formed here. Now, this side and this side are parallel. So a vertical line to this side is horizontal and a vertical line is perpendicular to this side. Given that this side is parallel to this side, the chosen base, vertical line must also be perpendicular to this side, which means that what we have in this region here, which I'll just shade, in this region here is a right angle triangle. We have a right angle triangle. And given that this side has a length of 10 centimeters and this side, I'll call this side AC. Side AC has the same length as side, I'll call this side DE. Because it's a parallelogram, opposite sides have an equal length. So side AC must have the same length as side DE. They must have the same lengths. Therefore, side AC must have a length of 10 centimeters. This means that BC must have a length of 2 centimeters because AB plus BC must be equal to the length of DE. So side AC and DE have the same length of 10 centimeters. So if from A to B is 8 centimeters, then from B to C we must have 2 centimeters, so the length of this side AC will be 10 centimeters. So what we have now is this right angle triangle here. So point B is this point here, this point here is point C, this point here is point E. H is the perpendicular height, this height here. The hypotenuse of the right angle triangle is 6 centimeters. This side has a length of 2 centimeters. So in order to determine the height, all we have to do is use Pythagoras' theorem. Pythagoras' theorem tells you that, in this case, the length of h squared plus 2 squared must be equal to the hypotenuse squared, which means that h squared plus 4 is equal to 36. And this means that h squared is equal to 32, and h is going to be equal to the square root of 32, and the unit is centimeters. So I just dropped the units over here. I'm just putting it at the end. So perpendicular height of this parallelogram is the square root of 32 centimeters. So HP is also known. Therefore, the area of the parallelogram is equal to the base, 10 centimeters, times the perpendicular height, which is square root of 32 centimeters, which means our area is equal to 10 root 32 centimeters squared, because it's an area which one can simplify using a calculator to obtain 56.6 centimeters squared. Now we're going to look at the trivial case of determining the area of a square and the area of a rectangle. This is something you've done before. You know that a square is a plane shape, which is such that all the sides have the same length. It has 2 pairs of opposite sides. It has 4 sides, and all the interior angles are angles of 90 degrees. So a square, plane shape, is a plane shape. All the sides have the same length, and all the interior angles are 90 degrees. That's a square for you, and it has 4 sides. In this case, the length times the breadth is the same thing as the length times the length. So the area of a square is simply L squared. In this case, if each side has a length of L, the area of a square is equal to L times L, which is L squared. For a rectangle, I'll label this side with L. The opposite sides have equal lengths. This side has a length of, let's take it as B. Opposite sides have equal length, so this side also has a length of B. The area of the rectangle in this case is going to be equal to the length times the breadth. So this is simple stuff. I could have chucked in numbers. So for instance, if I tell you that a square has sides with a length of 10 centimeters, to determine the area of the square, all you need to just note is that a square is a shape, a plane shape, which is such that all the sides have the same length, and all the interior angles are angles of 90 degrees. So you know that's what a square is. And if you're told that you need to determine the area of a square, and you're told that one side has a length of 10 centimeters, automatically you know that all the sides have a length of 10 centimeters, and the area of such a square is simply equal to 10 centimeters times 10 centimeters, which is equal to 100 centimeters squared. Now we're going to have a look at how to determine the area of a rhombus. This is something you've done before. In junior secondary school, a rhombus is a quadrilateral, which is such that all its sides are of equal length. So a rhombus is an equilateral quadrilateral. A square is a special case of a rhombus, but you don't need to worry about that. A rhombus is just a quadrilateral, so it has 4 sides, and all the sides are of equal length. And if you want to determine the area of a rhombus and you're given the length of its diagonal, so here's one diagonal. I'll label the side with A, B, C, and D. So if the diagonal AC has a length of P and the diagonal BD, which I'm going to show in red, has a length equal to Q. So the length of this vertical diagonal is Q. The area of the rhombus is given by this equation. Area is equal to P times Q. So the product of the length of the diagonals divided by 2. So simple as this. And that's something you can easily remember. If you want me to derive the formula, I will. One thing to note about a rhombus is that the diagonals divided into equal halves, into equal triangles. So I'll just show you. If I'm focusing on the diagonal with the length of Q, it's dividing the rhombus into this triangle here, roughly shaded in green. And this triangle shaded in blue. Roughly shaded. If you're focusing on the diagonal with the length of P, it divides the rhombus into, well, this triangle, essentially this region above the diagonal with the length of P, and of course the other triangle, which you can clearly see, this triangle here. So let's say I focus on the diagonal P. It divides the rhombus into 2 equal triangles. So I'm just going to pick the top half, this triangle. So this is A, this is B, this is C, just A, B, and C here. This side here represents this diagonal of the rhombus with the length of P. The height or the length of this other diagonal Q is known, and one other thing you need to know is that this diagonal, which I was mentioned before, splits the rhombus into 2 equal halves, which means it splits this diagonal into 2 equal halves. So from here to here is Q over 2. From here to here is Q over 2. So from point B to this point here, which I'll call O, and from point O to D, the line formed by between these 2 points. So points B and O can be joined to give the line BO, which has a length of Q over 2. Point O and D can be joined together to give a line OD, which has a length equal to Q over 2. And that's just because this diagonal of length Q has been split into 2 equal halves by the other diagonal P. All that means is that the perpendicular height of this triangle is Q over 2. Note that the diagonals of a rhombus are perpendicular to each other. So that angle there is 90 degrees. 90 degrees, 90 degrees, 90 degrees, and 90 degrees. That means this angle here is 90 degrees, this is also 90 degrees. And when you have a triangle like this, we know that the area is equal to half times the base. In this case, the base is AC. I'm choosing AC as the base, which has a length of P, times the perpendicular height. In this case, that's Q over 2. So this is the area of my triangle here, which gives me PQ over 4. Now remember, I just focused on this top triangle, but this triangle is the same as this triangle in terms of their areas. This diagonal with the length of P splits the rhombus into 2 equal triangles. We focus on the first one, top one, but the area of the bottom triangle is equal to PQ over 4. So I'm just going to say that the area of the first triangle, area 1, is equal to PQ over 4, where this first triangle is 1 and this triangle is 2. So triangle 1, triangle 2. Area of triangle 2 is also PQ over 4. So the total area of the rhombus, because the rhombus is essentially made up of 2 triangles, is equal to, let's do it this way, area of the rhombus, R for rhombus, is equal to area 1 plus area 2. So area of the rhombus is equal to PQ over 4 plus PQ over 4. and that's equal to 2pq over 4. What we're doing here, we're adding two fractions. They have the same denominator, so the denominator of the resulting fraction must be the same as the denominator of the original fraction, and the numerator is simply obtained by adding pq, well, simply following what you see, pq plus pq, which gives 2pq, and that's pq divided by 2, because 2 here is 1, 2 and 4 is 2, and that's the same thing I have here. Let me just remind you of how to add fractions with the same denominator. So I'm just going to move here so you're going to understand what I did. So imagine we have a fraction like this, 2 over 4 plus 3 over 4. The sum results in a fraction whose denominator is going to be the same as the original fractions, because we have two fractions with the same denominator and we're adding them together. And the numerator of the resulting fraction is simply obtained by following what you see. So 2 plus 3, which is what? 5. So in general form of the method I'm describing is as follows: a over c plus b over c. So I have a fraction here. The numerator is a, the denominator is c. A, b, and c are used here as variables. This other fraction has a numerator of b and a denominator of c. You can see that the denominators are the same, so the resultant fraction is going to have a denominator of c. And the numerator is just given by what you see, a plus b. A plus b over c. So this is the general form, and that's what I did here earlier, because I had pq divided by 4 plus pq divided by 4. The resulting fraction has a denominator of 4. Pq plus pq is 2pq. That gives pq divided by 2. 2 here 1, 2 here 2. In case you're confused about pq, you can think of pq as just another variable like x. X over 4 plus x over 4 is going to be, well, the numerator is going to be x plus x, which is x plus x, and you know that x plus x is equal to 2x. The denominator is 4, 2 here 1, 2 here 2, so x over 2. So it's the same idea I use here that I'm using here. So don't get confused that we have a product of two variables. The product of two variables is also a variable, so you can treat it like exactly how x was treated here. So be careful. So in summary, the area of a rhombus is equal to the product of its diagonals divided by 2. Next, we're going to take a look at how to determine the area of a trapezium. A trapezium is a quadrilateral. It has 4 sides, and it's such that it only has one pair of parallel sides. So this side and this side are parallel. The remaining 2 sides are not parallel. Once you have a situation like this, you have a trapezium. I'm going to label the side, so I'm going to label this side as having a length of A, and this other side as having a length of B. To make it clearer, A, B, C, D. So I'm using upper cases for the vertices. Side AB has a length of A units, whatever the units are. The side DC has a length equal to B units. So we're only interested in the length of the parallel sides. Now, like I said, when we focused on parallelograms, when you have two parallel sides, if you draw a vertical line that passes through the two parallel sides, if the vertical line is perpendicular to one side, one of the parallel sides is going to be perpendicular to the other parallel side. So I'll say that again. If you have two parallel sides, well, if a line is drawn through the parallel sides, if that line is perpendicular to one of the parallel sides, it's also going to be perpendicular to the other side. So keep that in mind. So what I've done now is drawn a vertical line. This base here is horizontal. I've drawn a vertical line. So that means it's perpendicular to this side AB, which means it's also perpendicular to this side DC. And we're just focusing on the height of the line. So from the base here to the top of the trapezium, this side can be said to have a height of h, which is equal to the perpendicular height of the trapezium relative to the chosen base AB. So I've chosen this base, well, side AB as a base. Even if I chose side DC as the base, the perpendicular height will also be the same h, because it's from this base to the top, or the bottom in this case. So the area of a trapezium is simply given by the sum of the lengths of the parallel sides divided by 2 multiplied by the perpendicular height. So I'll just give you here, the area is equal to half times the sum of the parallel sides, so A plus B, times the perpendicular height, in this case H. One thing you need to notice, which could be useful in some questions, is that from this point C, if I draw a vertical line up onto the line AB, the base, the height of this line is also equal to H, because these two sides are parallel and they are formed between two parallel sides. I mean, this is something you can see, and if you don't believe, you can also sketch a trapezium to see this, but this is something you need to remember. So I'll just call this point E. And the reason why it's useful to note this is because in some cases you will not be given the perpendicular height of the trapezium relative to your chosen base. But by having this here, what we have is a right angle triangle. You may be given the length of this side. Let's say you're given this side as 5, and you're given the length of this side, so from E to B is 3 centimeters. You can easily determine H here by using Pythagoras' theorem, because you have a right angle triangle here, and if you're going to apply Pythagoras' theorem here, it will be as follows: H squared plus 3 squared is equal to 5 squared. And you can make H the subject of the formula in this equation. So H squared is equal to 5 squared minus 3 squared, that's 25, minus 9, which is 16. And H is simply equal to the square root of 16, which is 4. We're taking 4 as the height of H. Now, I just want to stress again that the square root of a number, so for instance, square root of 16 is going to be equal to plus or minus 4, which means plus 4 or minus 4. But you know that the length or the height of a line is not going to be a negative number, so you take the positive number. That's what's done here. But just in general terms, if you have something like this, the square root of a squared is equal to plus or minus a. Just keep that in mind. So this is all you need to know. The area of a trapezium is equal to half times the sum of the parallel sides times the perpendicular height to the chosen base, which is going to be one of the parallel sides. If you're not given the perpendicular height, you might have to determine it by using this triangle I showed here. I'll just highlight it. By using this triangle, or this triangle EBC, which I'm shading roughly. So triangle EBC. By using this triangle, and to determine the height, you'll have to be given the length of this side and the length of this side. In addition, you can also form another right angle triangle by drawing a vertical line from this point here, D, which will be perpendicular to the base. So what we have is a right angle triangle. This region here is a right angle triangle. This height here is also H. So if you're given the length of side AD, so you were given the length as 13, and you're given that from A to this point here, which I'm going to call F. AF is, let's say you're told that AF is 8. You could easily determine H by also using Pythagoras' theorem the same way. Consider this trapezium here. These are the two parallel sides. You're given their length. One has a length of 4 centimeters. The other side has a length of 12 centimeters. The perpendicular height is also given. You can tell it's a perpendicular height because it's a vertical line drawn from one of the parallel lines to the other one, and you can see the symbol here, which tells you that this line and this line are perpendicular to each other. If you wanted to determine the area of this trapezium, all you have to do is say, well, the area is equal to half times the sum of the parallel sides. So the sum of the parallel sides is 4 plus 12 times the perpendicular height relative to one of the bases we've chosen. So if you choose this as a base, the perpendicular height is 10 centimeters. If you choose this side as a base, the perpendicular height is also 10 centimeters. So times 10. So the area of this trapezium is half times 16 times 10, which is equal to 8 times 10. Half times 16 is 8. 8 times 10 is 80. And it's going to be centimeters squared, because we have the unit of length given as centimeters, and that's what we use here. And it's as simple as that. Consider this trapezium. Now we're given that the side AD, so the trapezium ABCD, this side AD has a length of 13 centimeters, this side DC has a length of 12 centimeters. You're told that if you draw a vertical line from this point D, it intersects with the other parallel line, the line parallel to DC. You're told that if you draw a vertical line from D to the line AB, it intersects AB at the point E, and the length of A is 5 centimeters. He also told that if you draw a vertical line from point C down to the line AB, intersects the line AB at F, and FB is 3 centimeters. If you're required to find the area of the trapezium, what do you need? You need the length of the parallel sides and the perpendicular height of the trapezium, which is equal to the length of line DE or line CF. What do we know? We know the length of one parallel side, which is 12, so I'm going to say A is 12. I'm going to say EF is B, small b, and we don't know what that is. Or do we? The length of the other parallel side is AB, but EF is unknown. We know the length from A to E, we know the length from F to B. So I'm going to call this side B. The length of the other parallel side, which in fact I'm not going to call it B because it confuses with this, just call it X. Call it X. So the length of the other parallel side, so we know which is B, is going to be the length of side AB, which is going to be equal to the length of side AE, A to E, plus EF, plus the length of FB. Now AE is known as 5 centimeters, EF is not known, it's given as X, FB is known, 3 centimeters. So we have B as being equal to 8 centimeters plus X. What is X? X is 12 centimeters because essentially what you have here is a rectangle. Because you have a line here, you draw a line is drawn perpendicular to this line. This line is also perpendicular to this line because this line DE is perpendicular to the line AB, which means it's also perpendicular to this line DC. The line CF is perpendicular to the line AB, which means it is also perpendicular to the line DC. So you have a four-sided shape. The opposite sides are parallel. This side is parallel to this side. This side and this side are also parallel. So we have a four-sided shape, which means it's a rectangle. Opposite sides must have equal length in a rectangle, so X must be equal to 12 centimeters. That means B is equal to 8 plus 12, which means B is equal to 20 centimeters. So now B is known, but we need to determine the perpendicular height of the trapezium. And that's this height, the height of this side or this side. So the perpendicular height is equal to ED, or it's equal to FC. ED and FC are the same. So the line from point E to point D, the line from point F to point C. How do you determine H? Well, what you just need to do is notice that we have a right angle triangle, triangle ADE here, and Pythagoras can be used to determine the length of the unknown side, the perpendicular height, which is H, because we're given the length of 2 out of 3 of the sides of the triangle. So Pythagoras for this triangle is given as follows: 5 squared plus H squared must be equal to the length of the hypotenuse squared, which means that 25 plus H squared is equal to 169, and that means H squared is equal to 169 minus 25, which means H squared is equal to 144, and that means H is equal to 12 centimeters. So now that H is known, the area of the trapezium is given by half times A plus B, which is 12. So A is 12 centimeters. A plus B, 20, times the perpendicular height, H, which is also 12. So the area is equal to half times 32 times 12. Area is equal to, well, 2 here 1, 2 here 6, so it's equal to 32 times 6 centimeters squared, of course. So area of the trapezium is equal to 192 centimeters squared. So I'll just focus on the key trick of this question. You have two parallel lines. One is shorter than the other. If the length of this shorter one is 10 centimeters and this line is the line AB. The other parallel line is the line CD. So these two lines are parallel. AB is parallel to CD. This is a symbol that tells you two lines are parallel. Line AB and line CD are parallel. So I could just show this other symbol too on the lines. If I draw a line perpendicular to the line AB, so that's going to be a vertical line in this case. Because it's perpendicular to AB, it's also going to be perpendicular to CD because the line AB and CD are parallel. So keep that in mind. So same thing here. If I draw a line perpendicular to AB from any point, so I'm just drawing a line perpendicular to AB from the point B, it's also going to be perpendicular to line CD because the line AB and CD are parallel. So essentially what you have here is a rectangle, but the key thing here is that AB is a line with length 10 centimeters. The line EF is also going to have a length of 10 centimeters. So that was the key trick in the question that was just solved. That was the key trick. So what we formed here is a rectangle, but in the question we just solved, it turned out that, well, we were given that this side had a length of 12 centimeters. So essentially what we had was this trapezium. And these were the perpendicular lines that were drawn. Essentially what we obtained a rectangle, and this side was also 12 centimeters just from here. Here, it's 12 centimeters. It turned out that the height, this height here, which was the perpendicular height, was also 12 centimeters, which means that the shape formed, the shape here, is a square. Now I said it was a rectangle, but a square is a special rectangle. A square is just a rectangle where all the sides are equal. So I was right in saying that the shape form was a rectangle, because a square is a rectangle. A square is just a special case of a rectangle, the case where all the sides of a rectangle are equal. So there you go. So this was the key trick. If you knew this, or if you understand this, then you have no problem solving that question on your own, because all we did was determine the length of the parallel sides of the trapezium, side A and B, and determine the perpendicular height, and that was easily determined using Pythagoras' theorem. All we did was note that we had a right angle triangle, and we knew the length of this side and this side, so we could easily determine the length of the unknown side, which is the perpendicular height we were looking for.